so the last question for this test 9F part, question number 24 on the same page 134. So go there on your textbook. Let me read the question. How much momentum? So here we have to find the momentum. Usually this P is usually used as momentum. So let's just start writing momentum. This is what we need to find. Please remember, in our previous class, momentum is always mass into velocity. So let us see if it's given or not. M and V is there, means we can easily calculate. Of mass 10 kg, so mass is given, so this is given. M is there, 10 kg, so no problem with that. Mass is there, so we can get V. We can answer our question, momentum, right? If it falls from a height of 80 centimeter, so we can just write here, since it falls from a height of 80 centimeter, for any object that is dropped from the top. Before drop it was stationary rest, so initial velocity will be 0 meter per second. Since dropped from a height, any object dropped from a height in the beginning was always at rest before being dropped. That's why U will always be dropped 0 for an object being dropped. V will always be 0 for the object being thrown up, because at the top height it will stop for a moment, so V will be 0. But for drop, U will be 0. You know that, right? Then this is distance, so S is equal to 80 centimeter. But this is not SI unit, so we need to use this, the one we are familiar with: kilometer, hectometer, decameter, meter, decimeter, centimeter, and millimeter. We need to be thorough with these conversion factors, because this is going to be needed in many places. Okay, so here we need centimeter to meter, because meter is the SI unit. So 1, 2 places left means small to big, so 80 is divided by 1 place, 2 place means 20, 100 therefore, and centimeter therefore disappear, meter come in. So that will be 1, 2 places, so 0.80. So we need not write this 0. Meter is the height from where it is dropped, or the distance. Height and distance are same. Then that is given. Let's go and see. Take its downward acceleration to be 10 meter per second square. So A is equal to plus 10 meter per second square, because since downward acceleration, if it is thrown up, A would have been opposite to the gravity, so it would have been minus, but this is plus for sure, right? So let us do that now. Here let us go and see downward acceleration. So this is your downward acceleration. So here, see here, U is there, V is not there, so let us write your V. V, we need V. See, question mark is the final velocity. If we get V, we will get the momentum, right? Momentum generated. So our next task is to find out V. Now here A, S, U is there, remember that. So how about this? Since 2AS equal to V square minus U square. Why? Because we need V. So we have U is there, S is there, A is also there. Everything is there except V. So we can use this one now. V square equal to 2AS, and bring this one to the left side, then minus U square will become plus U square. Then 2A, we can now find out 2 into A is here 10, so we can just write here 10 meter per second square into distance here. Distance is here 0.8. So 0.8 meter plus U 0. So we can write here 0 meter per second, whole thing, square bracket must be there, because this is U square equal to V square. So that gives you here, this U stop, then decimal move here, so it become 8. no more 10. 8 to the 16. Then here meter into meter is meter square. You can bring this up again, then second to the power plus 2 will become second to the power minus 2. Plus 0 means disappeared, so it will be equal to v square. So if we remove this square from the v, then root will come here, 16 meter square, second to the power minus 2. 4 4s are 16 means single 4 will come out. Meter square will come out single meter, and second to the power minus 2 will become second to the power minus 1 to bring it out of the root. So v is exactly 4 meter per second. You can keep this one as 1. Therefore, your momentum P will be very easy, m into v. We already knew m. Now we have v also. So here 10 kg, you write down 10 kg into, and v here you see here. So write slowly, 4 meter per second, right? And we can write here since using equation number 1. So 10 4s are 40. I think they're just asking the numerical magnitude, so kg meter per second. So the momentum generated on this cardboard box, this is your answer. Okay, so if you want, you can write once, or that is also okay. Therefore, momentum, okay, momentum transferred is 40 kg meter per second in the original direction, because it is plus, right? The original direction of the fall means the direction of the falling of the fall. So if you can write here, which is positive, because it is positive, momentum transferred is 40 kg meter per second. Because it's positive, in the same direction the bell is falling from up to down, and the momentum is still in that same downward direction. That's why it's coming out plus. If it's minus, we would have said momentum is in the direction opposite to the direction of the fall, right? So that concludes your test portion, all done. Now you can give the test 9F. Okay, so that's done.